Good morning, ladies and gentlemen, dear colleagues. To start with, let me show you 3 videos, and I will ask you to think about which value of maximal flow rate would you pair with those urine streams. The video. Let's move to video number 2. And the last one is video number 3. And now let's check with the UroFlowmetry patterns. For the first one, we have a Qmax value of 14 milliliters per second. For the second one, the strongest one, we have a Qmax value of 26 milliliters per second. And for the third one, the weakest, we have a Qmax value of 9 milliliters per second. With that in mind, different flows for different values of Qmax, we encountered the idea of analogical uroflowmetry at the outpatient clinic. In the office, we do not usually have a uroflowmeter available for us. With that, we need to schedule the patient for a uroflowmetry and reschedule for the office afterwards to see the results. Total 3 appointments. What if we could estimate the Qmax of our patients by inviting them to choose an image out of 4? In the setting of a university hospital, we selected patients attending the uroflowmetry room between August 2018 and January 2019. Inclusion criteria were male over 18, in diagnosis phase because of LUTS, refer for uroflowmetry. The exclusion criteria were voided volume under 150 milliliters, blindness, mobility limitation, impossibility for stand micturition, or uroflowmetry labeled as non-representative. Guidelines for good urodynamics practice published by Schaffer in 2002, as well as European Association of Urology guidelines, were followed. For the first approach, and having in mind those clips I've just shown you, we configured this first 4-image pictogram representing 4 standing men in sagittal view with 4 decreasing urine streams. This first pilot image was assessed in 83 patients, and we found for the first that 93% of patients selected the 2 central images. With that, so decided to soften the strongest and weakest images, the streams, image 1 and image 4, achieving the final version of ANUF. As you can see now, the upwards flow of the first image is not that evident, and weakest flow is not discontinuous anymore. None of the pilot cases was considered for the results. We invited every candidate to drink half a liter of water, and later uroflowmetry was performed. Patient was then required to select the image that better represents the flow he has just performed. Afterwards, post-void residual volume was measured by ultrasound. Variables collected were age, ability to choose an image without help and time to do it, uroflowmetry pattern, arc-shaped, flattened, plateau, oscillating, interrupted, and superflow, Qmax value, Q average value, voided volume, ultrasound post-voided residual volume, and, of course, selected image. For the results, we make statistical analysis with R software and Spearman rank test, ANOVA, and TACI test for the results. 545 patients were selected, and 358 fulfilled the inclusion criteria. Excluded patients responded to several reasons, including majorly voided volume under 150 milliliters and decision to not participate in the study. Those 358 included patients had a mean age of 64 years. The UroFlowmetry global mean values are represented here in this table with a Qmax of almost 14 milliliters per second, a Q average of 7.5 milliliters per second, voided volume of 295 milliliters, and post-void residual volume of 51.55 milliliters. Arc-shaped pattern was the most commonly found, with 45%, followed by the flattened one in 31%. All patients were able to complete the questionnaire by choosing a representative image without help. Distribution of selected image was as follows: 6.4 for image 1, 24.6% for image 2, 54.2% for image 3, and 14.8% for image 4. Mean value and standard deviation of the Qmax were 20.4 milliliters per second for image 1, 15.5 milliliters per second for image 2, 13.5 milliliters per second for image 3, and 10.4 milliliters per second for image 4. A linear regression model was performed to calculate the confidence intervals for the Qmax of each image. Here, for image 1, you have a confidence interval ranging from 14.9 to 21 milliliters per second. For image 2, which goes from 13 to 15.7. For image 3, which goes from 11 to 13 milliliters per second. And image 4, which goes from 8 to 10 milliliters per second. Statistically significant negative correlations were found between ANUF and Qmax, and no statistically significant difference were found in the age or post-void residual volume distribution among the selected images. The feasibility of ANUF was optimal, and a correspondence exists between the selected image and Qmax. As well, we have been capable to establish confident intervals to predict approximately the range of Qmax of each patient depending on the selected image. Some limitations need to be taken into account. Firstly, obtaining data from a single institution might provide a selection bias. And secondly, it would be interesting to analyze several aspects of ANUF still pending, like, for example, its capability to detect change. So to conclude, ANUF is a useful, inexpensive, and understandable tool to estimate in an easy way the Qmax in situations where only an approximated value is required, or in the scenario where a UroFlowmetry is not available, offering a correspondence of each image with a range of Qmax. Thank you.
Thank you very much, Dr. Berto. And now this presentation is now open for comments and questions, please.
I have a question for this. After Peter, but
Peter was here. I like it. It's good. The scheme was presented 2 years ago, I think, at the ICS, and then you elaborated on that. It's fantastic. One comment is that I think you showed on the slide not standard deviation, but standard error of the mean. So, but it's other than reported in your abstract. But my real questions and basically my challenge is for you is, can you compare what you do now with the pictograms with voiding into a beaker, a measuring beaker with a stopwatch? You will get a very reliable mean flow in that way.
You mean comparing this pictogram with what?
With voiding into a funnel in a beaker with the measuring, volume measuring.
Good.
So you measure the volume and you ask the patient to record the voiding time. With the stopwatch. Can be done on every phone.
Yeah, are you
So
talking for?
you will get a mean flow.
Yeah, this
Can you
application.
compare this one with the other one?
Yeah, it would be really interesting to compare this voided volume or even the record for and compare it with that.
And then the question is the clinical question. If I'm going to apply this one, so, and my patient scores C,
Yeah.
does that patient get any treatment
I have a
or not?
comment on it.
Yeah, to take this to make clinical decisions and indicate a surgery or a program, any therapeutic management, I think we are not in that point now.
So that's what we are.
We are getting to it because we have something really that is this susceptibility to change that is pending, and even test this one in not clinical patients, I mean sane patient, non-diseased, that is not done. And with that pending, we hope we can achieve this soon.
Excellent.
Well, Sharif, you have a comment?
Yes, I have a comment on this because I think that there is always the patient subjective fallacy that will be there because many of our patients, for example, when you ask them about the stream, how it looks like, he said, I'm very good, I'm normal. And when you put him on the UroFlowmetry, it is really obstructed. Peter, I want you to be there for this. So I think that the UroFlowmetry is really different from this one. And there is definite subjective fallacies that will happen. Besides, then I want to comment also on what Peter said, that you ask the patient to do a stopwatch. This will be very unphysiological because the patient is holding his penis with one hand and the stopwatch with the other hand. This is like a very bad test. I'm sorry.
Please.
Salvador Arlandis from the same institution like Dr. Rogel. I agree with you completely. I'm going to appoint that idea because I think that it's not so physiological, it's not so easy for many patients. And I think that the idea of Dr. Rogel is very nice and attractive because it could be it's very sensitive maybe, but we have to try this tool with a pathological situation, specific pathological situation, and a specific, just to try to, if there is sensible to changes, to intervention, to treatment, after therapy, after medication, or things like that, because the tool is just growing, and the birth of the tool is just very recently. So there is many things to do with this tool, and just to validate, this is only the first steps. And I think that it's very useful for the office when you don't have access to a UroFlowmetry. That's our opinion and our idea, what we are developing.
And
Thank you very much for that additional comment. Thank you. And thank you very much, Dr.
okay,
Bertel.
just one little question going to that point. We have detected using the ANUF that even the patient uses it to show love to the doctor or even to punish him after surgery. After urethral stricture surgery, we have detected some patients say, no, I'm worse than the worstest one. That's a different way that this is going as well.
Okay, thank you very much. Thank you.